So the first phase of this lesson, we are going to talk about solids of revolution. What that means is that we take a 2D shape, a triangle, a rectangle, and we revolve it about an axis, and that revolution creates a 3D solid. So we're taking a 2D shape, mostly polygons, but not all polygons, rotating them until they form a 3D solid. All you can think about is the Earth, the rotation of the Earth. Okay, so how we're going to begin this discovery is with a pencil and a Post-it note. Okay, so if you do have a Post-it note and a pencil, I want you to take that Post-it note and stick it to your pencil like it shows in the picture. It says to cut it in half. We don't need to cut ours in half. Should be fine using the whole thing. It should work. And then I want you to twirl your pencil around and try to picture what 3D solid you're creating when a rectangle revolves about an axis. Can you see it? Yes. Maybe if I do it this way. Nope, you're like, nope, that's just a Post-it flapping. I'm going to try to make mine more rectangular. Yours isn't sticking. You got a non-sticky sticky note? Okay, let's try this. Ooh, I can see a cylinder. Can you? I can see a cylinder. Turning my Post-it note into a right triangle. It's okay if you just want to watch. And I'm going to attach my Post-it note like it shows on the notebook page. So now I've got a right triangle with one of its legs. And when I spin this around, do you see a 3D solid? Dun, dun, dun. Yes, you do, right? It is a cone. You got it. Okay, what parts of the cone do these sides become? So here's our right angle. What does this become? What does this become? Does this become anything? Let's talk about it. So that first one becomes the radius of the cone. Ooh, that's the height of the cone. And very nice. Even though we haven't studied cones yet, that becomes the slant height of the cone. Very nice. A cone is a solid revolution of a right triangle around one of its legs. Now that's very important, that you're rotating it about either one of its legs. Very important. Now what happens if we don't rotate it about its legs? What happens if we rotate it about its hypotenuse? Okay, so I'm going to have to use some tape for this one. So I'm taking my Post-it note. I am taping it to my axis where I'm going to revolve it around. And now the hypotenuse is attached. A 3D diamond? Yeah? Okay. What is it? So what we call this, what we call that is a double cone. You probably didn't know it was called that. Yeah, I didn't know it was called that before I researched it. So when you attach it, so this is a big deal. If I rotate it about one of its legs, I produce a cone. If I rotate it about its hypotenuse, or if I rotate a triangle that's not a right triangle, I get a double cone. That's not really one of the shapes we're studying. It's just two cones. It's called a composite figure. It's two cones combined sharing their bases. You share it. Okay? So These two cones would have the same base, and they may or may not have the same height. You can make a double cone, and the cones not be congruent. That happens. That totally happens. So had mine not had an isosceles right triangle, I would have made a double cone that was not congruent on either side, okay? Okay, question for you. Do not type your answer yet. What 2D figure could be rotated about a vertical axis to produce the following solids? So I want you to have an answer for A, but don't type it, a different answer for B, and a different answer for C. So it's like you're working backwards. Here's a 3D solid. What 2D figure was rotated to produce the solid? Yeah, we've already done B and C, but that's okay. Ooh, I think almost everyone got it right. Very good. So what was the 2D shape before it was revolved? Pretend that my semicircle is more circular, more perfect, more of a half circle. So anyways, yes, you've got a semicircle, but it's like attached kind of by its diameter, okay? Then you've got a right triangle. You can't say triangle, you must say right triangle for part B. And then part C, your answer was rectangle. Rectangle or square, but squares are rectangles, so you have that covered. Okay? So that, okay, now we're going to go the other way. You'll get to play with that in a moment. Now we're going to go the other way. So here we went from flat, 2D to 3D. Now, a cross section is when you go from 3D and you chop it and you get a 2D look at your figure, a 2D look. So a cross section is when you ask yourself, if a plane, I'll use my ID, if a plane intersects a solid, what 2D figure would result? What 2D shape would be formed if I slice a 3D solid with a plane? Okay? Not that kind of plane. So, if you have Play-Doh, which I know some of you don't, I want you to make a sphere with your dough. Everyone else can just watch me. So, Exhibit A is sphere. Mad Play-Doh skills here. So, what I'm going to do, I think I'm going to switch to my hover cam. So now what I'm going to do is take my sphere and some good old dental floss, and I am going to slice through my sphere with my dental floss. And the 2D figure, oh man, pretend it's better. It's a little egg-looking, egg-shaped looking. The 2D figure that results is, of course, a circle. Now, I tried to go through the center of my sphere. That's called, when you have a cross-section of a sphere through the center, the circle you create is called the great circle. Not the mediocre circle, the great circle. Get it? Okay, but what if I sliced through my sphere and I did not go through the center? Tell me what you think would happen. I want some hypotheses. I'm going to slice through my sphere, but I am not going to go through the center. So, back to sphere. There we go. Slice through it, but not through the center. I'm going to kind of go diagonally. It's just hard because it distorts my sphere as I cut through it a little bit. Do I still get a circle? Do I still get circles? What do you think? Yes? I get a radish? Okay. So, but how does this circle compare to my great circle? So it's still a circle, but it has a smaller radius. Yes, smaller diameter. Okay. Let's move on, and let's do cylinders now. If you have Play-Doh, try to create a cylinder with your Play-Doh. It's not as great. Yes. I'm not too interested in what I get if I cut this parallel to the bases, because come on, What are you going to get if you cut it parallel to the bases? A circle. Okay, we've kind of already gone through that. So instead, I'm going to cut it perpendicular to my base. I'm going to cut it perpendicular to my base. I can go through the center or not go through the center. It doesn't matter here. But it does matter that I'm perpendicular to the base. I didn't get all the way through there. There's going to be a seam. Oh no. Ah. Fail. Fail. Okay. Autofocus, you can do it. Okay, pretty bad here, guys. But if you take the cross-section of a cylinder and you're perpendicular to the base, you should get a rectangle. Oh, yay, Alex is in. So last one, I'm going to make a new cylinder. What happens if I just go crazy and I cut like diagonally through the cylinder? Like how many shapes could I form? What types of shapes? So think of this kind of getting cut at a weird diagonal. What do you think could result? Go ahead, yeah. I heard triangle. I'm hearing trapezoid. What do you think we could get? I'm trying my best. Now the problem here is that yes, this looks trapezoidal, and yes, this is a segment. This is not a curve, and this is a segment. But is this part curved to get us there? And that's what we're going to discover with our online simulation that we're about to do. So yes, I realize when I go diagonal that these are not the same length. This one's longer than this one. Tick mark, double tick mark. They're two different lengths. But is that a trapezoid? Or is it like some sort of like ellipse or something that has curved sides, therefore it's not a polygon? Okay? So it's not a rectangle though, because opposite sides are congruent in a rectangle. So it's either a trapezoid or it's neither. And that's what we're going to discover through our next activity. So this is going to be our exit ticket. Before we leave class, I want you to know in a cylinder, and you're going to do it with other shapes too, in a cylinder, what cross-sections can and can't result. Notice I actually didn't even have a trapezoid as a choice. So we need to figure out which ones go in the yes box and which ones go in the no box. So we want to do this before class is over. Now, I need you to get your discovery that looks like this. And I need you to head to the website on my calendar. Go to the website on my calendar and click on the one that says cross sections. We're going to start on cross sections, then we'll do solids of revolution to end. So you can play along with me. You can be on this site with me and kind of open and close your windows, okay? What we want to decide is we want to find every cross section possible that can result from a plane intersecting a cone, okay? So the fun thing is we can play with, I'm going to uncheck this. Right now our cross section is a circle. But we can move these sliders and, oh, now our cross-section is an ellipse. You can rotate these, you can move your slice, you can make it thinner or thicker. Let's try to get perpendicular to the base. Ooh, now it's a parabola. Now it's half of a parabola. Could we get it to be a triangle? Isn't that pretty? Look at that. Ooh, right there. I bet if we landed perfectly, even though it's not telling us, that we could get it to be a triangle. So we know our cross sections can be an oval, a circle, a triangle. Could you think we can get anything else? Yeah, you clicked animate on all of them? Okay. Yeah, it kind of takes you through all the different shapes that can occur. Most of them are just kind of little parabolas, or kind of like what looks like a half circle, but it's not circular, it's ovular. So, yeah, the double cone is cool, but we're not doing the double cone, because we want to do ones that we're studying in class. Okay, so I got triangle, oval, circle. Did y'all find any others? Let's move on to cylinder. What 2D polygons can result when we intersect a plane with a cylinder? So we're going to agree with rectangle and square, right? You can get a rectangle, you can get a square, depending on if your diameter is congruent to your height, right? If your diameter of your circle is congruent to the height, then you would have a square. So we've got square, rectangle. Anything else? Oval, circle. See, if you notice here, we can't really get a trapezoid. We can get something that really looks like a trapezoid, but you see how they're curved sides? So it's almost trapezoidal, but a trapezoid needs to be made up of segments, and that has some curves, okay? I see some parabolas in that weird not trapezoid thing. Yeah, that's the weird not trapezoid thing. I don't think we can, but if you can convince me. Jesselyn, that was the... You think you got one? You can share your screen if you want. I'm getting lots of isosceles trapezoid or triangles. Scalene. Some cool kite-looking figures. I don't think I can make one. Scroll all the way, the faces all the way down. No, the angles can't be 90. Okay, did you request control? I don't see even close to a right triangle. Angle at the top? Should the pyramid must have congruent lateral faces? Thank you for asking, Sharon. So if you okay, let's move on to prism. So it's kind of fun, huh? What in the world is that? Start playing with the other website, please. Oh, pencil brand. Okay. Start playing with the other website, please. Okay, you have to go. Do your homework. I don't know if you see, but my computer is literally not reacting to me. Does anyone want to go to the other website and share their screen? Thank you. Okay. So I want you to do 3 vertices. 3. Okay, do 0, 0, 0, 10, and 10, 0. 0, 0, 0, 10, and 10, 0. And then click New Polygon at the bottom. There we go. Okay, do New Polygon. Do 3 vertices. Let's do 3 vertices again. I'm going to tell you different ones. Do 0, 10, 8, 0, and 0, negative 10. For the last one, 8, 0. New polygon. No. It's supposed to be 0, 10, 8, 0. Can you change the vertices? Make that top one 0, 10. Eight, 0, and 0, negative 10. I'm trying to help you make a double cone here. New polygon. Yay! Okay, our lesson is over. You guys need to try your homework tonight and bring questions tomorrow. We're going to do cones and spheres tomorrow. KK.